So the second set of notes for today, this is derivatives of specifically inverse trig functions. So these are inverses, but specifically inverse trig. We don't use them a ton, but they do like to throw them out every once in a while, so you do need to know them. Of these six, you're like, Mr. Arbone, those are six random functions that I have no idea what they are. Like, how am I ever going to memorize these? Of these six, sine and tangent are probably the most common. So you really, really, really need to know those two. And then of the other three, the other four, probably cosine and secant jump in the next common after that. But obviously, you do technically need to know all of them, but you really, really need to make sure that you know sine and tangent. And then just as a general note, they will switch between the two notations, but arc and the -1 notation do mean the same thing. So whether they say arctan or they say tan to the -1, they both refer to that inverse derivative. I prefer arc because it's easier to write. You don't get it confused with the -1 power. But they will sometimes throw in that -1 notation instead. Okay. So these are very formulaic. Okay. You really just apply the formula. They're not going to try and trick them up too much. These are also all chain rules, so we do have to consider them as a chain rule, think of them as a chain rule derivative. So let's look at an example. So number one, I have arc sine of 2x. So 2x is my u, or my chocolate, my inside. Arc sine is my outside. So I'm really just applying the formula. So arc sine's derivative is u prime, so the derivative of u, over the square root of 1 minus u squared. So the 1 minus the original squared. So u prime derivative of 2x would be 2. Okay. And then everything else, I just kind of plug in from there. So square root of 1 minus. Okay, if you notice, I am checking this a lot because even I don't have these memorized really. And then the original squared, so 2x squared. Okay, and you can leave it like this. You can leave it as 2x squared, but if it's a multiple choice question, more than likely you're going to see that simplified. So this would just be 2 over the square root of 1 minus 4x squared. I get this question every year. Mr. Arbone, do we need to try and factor that and get the square root to cancel out or rationalize? No. You will probably see that as your answer choice. 2 over the square root of 1 minus 4x squared. They're not really going to try and oversimplify these because just remembering the formula is already a, hey, you know more than most calculus students because it's just a lot of formulas to memorize. Okay, let's look at another example. Number 2, we have y is equal to -3 arctan of 3x. Okay, so the important thing to note in this one, we have a constant being multiplied. So we need to make sure we multiply our entire derivative by -3 at the end, because that -3 is going to be left alone, but we still need to have it in our final answer. Okay, so y prime is equal to -3. So I'm just going to keep that on the outside. And then I'm going to apply my arctan derivative formula. So arctan is u prime over 1 plus u squared. So u prime derivative of 3x is just 3 over 1 plus u squared. So 3x squared. And then I can just kind of simplify from there. So y prime is equal to -3 times 3 is -9 over 1 plus 3x squared is 9x squared. Nice and easy. Okay, so these are hard to remember, but they don't really trick them up too much. They're pretty straightforward. You're just kind of plugging them into the formula. Okay, let's do 2 more. So y is equal to arc sine of the square root of x. So once again, square root of x is my inside. I'm applying my formula. Okay, u prime over the square root of 1 minus u squared. So y prime is equal to u prime, so 1/2 x to the -1/2 all over the square root of 1 minus u squared. So 1 minus square root of x squared. Okay. And once again, you can leave it like that, but if we did simplify this, this would be y prime is equal to 1 over 2 square roots of x square root 1 minus x. Okay, I can't really combine from there. X and 1 minus x are not the same base, so I would just leave it like that. Okay, you could technically, since they're both square roots, you could multiply the inside. So if you wanted to, you could change this to be 1 over 2 square roots of x minus x squared. If you wanted to further simplify it from there. But once again, you don't have to simplify it. You can leave it as that very first step. The only reason you'd simplify it is if it's multiple choice and all the answers were simplified. So you just want to make your answer match one of the answer choices. Okay, last but not least, number 4. It's the trickiest one. Y equals 2 arc sine of e to the 2x. If you notice, all the examples I gave you were sine and tan because they're really the ones that we use the most. Okay, so y equals 2 arc sine of e to the 2x. So y prime equals 2 on the outside, so I'm going to make sure I keep it outside. Okay, arc sine is u prime over the square root of 1 minus u squared. Just reminding ourselves. Okay, so u prime, e to the 2x, that is a chain rule, so it is e to the 2x, because it stays the same, times 2, all over the square root of 1 minus e to the 2x squared. Okay? And as always, y'all, I can simplify from there if I want to. So if I wanted to, this would become y prime is equal to 2 times 2, so 4 e to the 2x all over the square root of 1 minus power to a power, so I multiply the powers. 2x times 2 is 4x, so e to the 4x. Just like that. Okay, so those are really inverse trig derivatives. Nothing too crazy about them. We're just plugging them straight into the formula. They're not going to get too tricky. Like, they're not going to really throw them into product rule or quotient rule. Those are already tricky enough. So they're going to be pretty formulaic. They're pretty straightforward. You just really need to know the formulas. And then, watch out for little things like constants being multiplied, chain rules on the inside, like the e to the 2x, something like that. And then remembering, just like our original trig rules, sine, tangent, secant are all positive. Cosine, cotangent, cosecant, so if it starts with a C, they're all negative. Okay,